Hello, everyone. Today, we want to discuss momentum theory, windmill brake descent for a rotorcraft helicopter. Once again, today we want to discuss and analyze the momentum theory, windmill brake descent. Let's assume we have a schematic of an helicopter hovering in a descent direction, that is downward, and let's assume we have the, the position A, the position BC, and position D. Also at position A, we have the VA, that is the velocity at A, and the R, and we have the velocity at BC, and we have the velocity at D. And we have an induced velocity at A pointing down on the helicopter, and we have the thrust of the helicopter pointing up, and we also have the induced pointing down, and the descent pointing up. So this becomes V infinity. This one pointing up becomes thrust, and the one pointing down is the induced velocity at BC, and this one is VD. So therefore, our VD equals the descent speed, and our VID equals the induced velocity at BC, and our V infinity equals the induced velocity at A and our T equals the thrust of the helicopter. And don't forget that induce velocity direction is always opposite to the thrust direction. We have the V infinity, we have the thrust, and we have the V velocity of induce, and we have the descent. This is A, BC, and D, and this is VA, VBC, and VD. Our VD equals the descent. Speed. Our VID equals the induce. Velocity. At BC, our V infinity equals induce velocity at A. So therefore, using the point of reference or know the direction of the velocity, we can deduce mathematically that VBC equals VD minus VID. That is the velocity at the point VC equals the velocity at D minus the induced velocity at point BC. So therefore, VID equals VD minus VBC. That's the first equation. And don't let us forget that VA equals VD minus V infinity. So therefore V infinity equals VD minus VA as the second equation. Equation 1, equation 2. Now, by applying Bernoulli's equation on the upper region and the lower region of the windmill momentum, we can deduce that by applying one on the upper region of the windmill you can deduce that the V infinity is acting downward and the thrust at the middle is acting upward, and this is A section here, and this is B. After dividing the region, then we can deduce that this is VA and this is VB. So therefore the Bernoulli equation becomes PA plus half rho VA square equals PB plus half rho VB square. And that's the upper region application of Bernoulli equation. Two, by applying Bernoulli equation on the lower region. We can deduce that the lower region form the lower part in such a manner with the thrust of the helicopter propeller pointing up and the induced velocity VID pointing down at section CB. and the velocity of the descent pointing up. So this become C and this is D. This is VC. This is VD. Now by applying the Bernoulli's equation, just like we did for the upper part, we can deduce that the PC plus half rho VC square equals PD plus half rho VD square. And from here we can deduce the thrust TR, or TR equals PC minus PB equals multiplied by area, which becomes PC minus PB by R squared. Don't let us forget, from the Bernoulli equation we can deduce our PC. Our PC becomes PD plus rho plus half rho VD square minus half rho VC squared. And our P B can be deduced to be PA plus half rho VA square minus half rho VB squared. And this can eventually become since PA that is the pressure at A, equals the pressure at B, due to the assumption of the momentum, and VB equals VC, we can deduce that PC minus PB equals half rho V squared D minus half rho VA squared. Also, since VA equals VD minus V infinity, then we can slot the VA into this part. our PC minus PB equals half rho VD square minus half rho VD minus V infinity squared. Our PC minus PB equals half rho VD square minus half rho VD square minus 2VD V infinity plus V infinity squared. Then our PC minus PB equals half rho VD square minus half rho VD square minus 2VD V infinity plus V infinity squared. So PC minus PB equals half rho 2VD V infinity minus V infinity squared. VD cancel each other. So PC minus PB equals half rho 2VD minus V infinity bracket. And this become our PC minus PCB equation. Now, the momentum let's just forget that the momentum from the thrust equals minus m dot VA minus VD is equal to m dot VD minus VA, and m dot equals the mass flow rate during the brake descent. From there, you can deduce that V infinity equals VD minus VA, and V induced equals VD minus VBC. so that the thrust will be m dot v infinity. And the m dot, which is the mass flow rate, equals rho AA VA equals rho AB VB is equals to rho AC VC equals rho AD VD. From section A to B to C to D, so the mass flow rate is constant. The momentum theory, just like we assume from the momentum theory of the windmill brake that the mass flow rate will be constant from one section to another. And once again, these are the mass flow rate. Now that VID equals VD minus VBC, which is also VBC, equals VD minus VID. Then the mass flow rate at BC equals rho ABC VBC, which is rho pi r square VBC. And don't let us forget that VBC is VD minus VID. So we slot in this into this. So our mass flow rate at BC, that is at the propeller section of the helicopter, becomes rho pi r square VD minus VID. So the thrust equals the mass flow rate at BC multiply by V infinity. So therefore T, which is the thrust, becomes rho pi r square Vd minus Vid multiplied by V infinity. And this is another major equation we'll be needing very soon. Now that we have thrust to be rho pi r square Vd minus Vid multiplied by V infinity, then we can also deduce that Pc minus Pb equals half rho 2 Vd minus V infinity over V infinity. And the thrust can also be pi r square times half rho 2 Vd minus V infinity. From the previous equation, multiply by V infinity. Then T equals rho pi r square into Vd, that is to cancel this Vd, minus half V infinity V infinity. And this is another equation to be compared. So when this becomes equation 1 and this becomes equation 2. Now, by comparing equation 1 and 2, you can see that V infinity cancels V infinity, and this cancels this, and this cancels this. Then the only remaining balanced entity equals V induced equals half V infinity. So therefore, and this is equation 3, and V infinity equals 2 Vid. This equals equation 4. So our thrust T equals 2 rho pi r square Vd minus Vid multiplied by Vid. So therefore, the thrust, the final thrust equation for an helicopter in a windmill at the descent velocity equals T equals 2 pi rho pi r squared Vd minus Vid into Vid. Thank you very much for staying tuned.